am I getting that? Alright. Okay, this is making this video. Well, it's a live stream actually, but I'm making a video for YouTube for a short update. Alright, the previous board I made, I had some issues with the with noise and problems, so this is a new version I'm designing in designspark. So I couldn't find all the library items I wanted to use, but I basically made a choke. Now actually these great big red blocks right here, they're actually ferrite chokes, but they're too big. So anyway, the footprint on the board is quite large. But anyway, I've actually used two of these, which represent one ferrite choke really, and the ferrite choke was going to sit on the board, and it'll be a lot smaller than that anyway. So this new design's got two regulators. So I've got my 12 volt regulator there, which drives my the TL494 IC, and I spent the last 2 or 3 days designing and redesigning the flipping board because I wasn't happy with it. Anyway, this is the opto isolated stage, but it's not really opto isolated. I mean, it's using the opto isolated chips to drive the output stage, but that's mainly just to prevent noise from getting back into the oscillator section, which is down here. Because if you have direct coupling, and because I'm pulsing coils, as you probably saw in the previous video, the amount of back EMF and pulses and things like that and RF is a big problem. Well, the best way to get rid of RF is to opto-isolate it and decouple from it. So hopefully the opto-isolated circuit will keep the RF from getting into the critical oscillator section here. And the voltage, well, it's no longer a doubler or a tripler, it's actually 6 times. So we're expecting probably around 120 volts on this, but it's low current, very low current. So because of that, it's not. This is mainly going to provide the voltage for testing. You know, it's mainly going to be like a basic voltage to keep the circuit running. But I have to supplement that energy from an external source, which is a Chinese thing, which I'm going to connect to this. So I've got a socket at the top there, where I put my input, 120 volts input, into the board, which is what supplements the actual circuit, which is a H-bridge, which I found online, and I drew it up, and I've got my BS170 MOSFET driver. They're basically baby MOSFETs, you know. So they're going to drive the positive MOSFETs, which there's 2 of those. So there's the NMOS, there's another NMOS. Sorry, that's a PMOS. So when that NMOS is on, this PMOS is on, and this PMOS is turned on by this MOSFET here. It's alternatively turned on by pulses, you know, with a dead zone. That's a dead time in between each pulse. So when that MOSFET and this MOSFET has been pulsed, there's a gap, a space, and then this PMOS is turned on by this little baby MOSFET driver, and this MOSFET driver is turned on as well. So I've got balance controls to balance between the NMOS and the PMOS. So there's a trimmer for each of the stages for balance, you know, basically in series with the biasing. And the biasing is down here. We turn these pots up. Well, they don't look like pots, they look like brick. Yeah, I'm not going to say it. But look like outhouses anyway. They haven't got any holes in them, but yeah, you can't see inside, so they must be private. Anyway, so I've got 2 biasing trimmers there. Now the opto-isolator section, I've got some LEDs on here. The main purpose for the LEDs is because the opto-isolators, you can't actually see what's going on with them, because they're encased inside a shell, and you can't actually see when they're blinking, when the LEDs inside them are actually up because they're infrared or something. And so these LEDs basically are in series with the opto isolators, and they will light up when the opto isolator LEDs are lit up inside, so we can see what's happening. We can see when it's been activated. So that some of these are on the pull down section, which turns the MOSFETs off, and some of the LEDs are on the pull up section, which is what pulses the MOSFETs on. So this is the pre-driver, and then there's the oscillator driver, which is TL494, which I've isolated, and I've also spent some time with a little bit of screening on the back, a little bit of ground shielding, and that's in between the high voltage section over here, which is generating the voltage, which preliminary voltage, which is just basically to tickle it, to get it to run for testing, so I don't blow anything up, because the voltage on this is capacitor coupled, so it's basically like a voltage ladder, and diode pump. It's called a diode pump, so it basically goes through to 1N914 diodes, and they can't handle a lot of current, about 200 milliamps, so you can't expect to get a lot of current out of the output, because the 1N914s can't handle more than 200 milliamps, so we don't expect to get a lot out of this circuit. But it's there because I need it right now, and I haven't got the Chinese thing which I've ordered, and I need a way of testing it and setting it up, so that's what that circuit on this side of the board is for. Anyway, there's the driver section there, which I've managed to sort out and tidy up and get rid of a lot of elongated tracks and condense it and everything. And that's my pre-driver, which I've spent the last couple of days designing, then redesigning, because the previous one was a complete rat's nest. There was tracks, it was zooming, wiggling and winding all over the place, and I had to relay it all out, and I finally got it just the way I want it. And the H-bridges on the back, as you can see, I've used really heavy gauge track. Well, when it's etched it will be. So I've basically done it symmetrical, so that it's balanced, so that any noise that we get is basically cancelled out, because it's in basically like an E-shaped ground plane section, so it's kind of E-shaped and mirrored, and so it's basically should enclose any EMF or magnetic fields within this area, so it shouldn't escape and interfere with the oscillator. Anyway, so I've got two, you can't see them here, but there's two big capacitors on the board. I'll turn it over. They're actually wired in series, so the C26 and C16, and they're in series, so each one's about 50-60 volts, so between them the whole voltage will be across it, only about 4. Well, they're rated at about I've forgotten now actually. I think they're 1000 microfarad, but when they're in series it'll only be about 500 microfarad, because in series, because they're just the reservoir capacitors, which the MOSFETs will pulse, send 2 or 3 millisecond pulses out to the coil, and it will take that energy from the capacitors, and then we've got like 40, 50, maybe 60 milliseconds for them to recharge from the charge buffer down here, which is all these little capacitors down this area down here. So, which is driven by a timer, an NE555 of all things, yeah. So anyway, that's just a little update what I'm doing at the moment. Anyway, hope to see this. Let's hope to see this working in the next week or two or so, when I get it made, and etched and everything. And yeah, it's going to be fun. I'm still tweaking things on the board right now. I'm just fiddling around with little tweaks, like things which I'm not happy with, but most of it's sorted out. There's just a few little areas that I want to try and tweak a bit better. So I thought it's time I did a YouTube video, because the live stream's shutting down apparently in in July, so I won't be able to do any live stream videos with my existing camera, and I'm not sure if I can do it offline. I don't know. I don't think it works unless I'm logged in, so I don't know how that's going to work. Anyway, thanks for watching.